Okay, so here we go with the next video in our kind of little mini series here, getting us ready for potentially National 5 applications of maths. And so in this one, what we are going to be looking at is we're starting to look at statistics. And in this one, we're looking at averages and spread. So, linked to our previous learning, we should all have previously done mean, median, mode, and range. In terms of what we're going to be doing as part of this video is we are going to be making sure that we can calculate our mean, median, mode and range, and then two new things which are IQR and SIQR, which stand for interquartile range and semi-interquartile range. We're going to be able to create 5-figure summaries. We're going to be able to create box plots using that 5-figure summary, and we're going to be able to compare different averages and spread. So how we're going to be successful with this, so all of us should be able to calculate all types of average. Most of us should be able to successfully generate a 5-figure summary for a set of data, and some should be able to successfully create box plots and be able to compare the data accurately and correctly. So averages. There are 3 different types of average. Everywhere but maths, they tend to only use one of these and just call it the average. But to be truly correct in statistics and maths, there are 3 different types of average, not just the one. So the first one is the mean, and this is the one we get when we add together all the data points we have and divide by how many values there are. This is the one that when other subjects talk about finding the average, they will be talking about the mean rather than any of the other two. So mean is written in maths just as a little shortcut as x with a line over the top. So instead of having to write out the word mean every time, you can just write that little algebra x with the line on the top. It's not the end of the world though if you write the word mean. So, second type of average, we have the median. This is where we put our data in order from our smallest number to our biggest number, and then we find the one that's literally in the middle. And then our mode, which is the number, or sometimes it can be more than one, so numbers, that appear most often when in your lot of data. So in your list, if there's a number that appears more often than every other one, that is the mode. Okay, so examples of these. So if we have a class of 15 pupils sitting a test, the results are shown below. What are the mean, median, and mode of the test scores? So here's this list of 15 numbers. So to find the mean first, we add them all together. So we're adding up all those 15 numbers. If you see on the top line, there should be all 15 there in a nice little row. Divided by 15, fractions just mean division. So we end up adding the top together, we get 110. Divided by 15, so we get the mean is 54%. Median, first things first, we need to put them in order from smallest to biggest. So you'll see in this case they're in order, so it's 3, 9, 32, 33, 50, whereas in our original list the numbers were just in any random order. So now we can find the middle, so we do this by splitting it into our top half and our bottom half. So we've got 7 numbers as part of our bottom half, 7 numbers that are the top half, and so the number that's in the middle, left on its own, that is our median. So our median is 53. Last one is our mode. Quite often it makes sense to put our numbers in order from smallest to biggest here to spot our mode most efficiently. Apologies for the typo in here. I meant to change it, but I forgot. And now that I've started the video, it's harder to do, and I would need to go back and do it, and then so leaving it there. That first number should be a 3%, as it is everywhere else. So we can see in our list 4, 9, 32, 33, 50. They all just appear once. But we have 52 that appears twice, and there's no other number that appears more than once. So 52 is our mode. So mean, add them up, divide them, median, split in half, and the mode is the most common one. So there's something else we need to speak about median before we go into our next thing. So calculating our median for an even quantity of data. So when there are even number of data points, our median becomes a little bit less obvious. So what happens is we end up with our bottom half, our top half, and there's no number in the middle. but our median still sits in the middle between our bottom half of our numbers and our top half of our numbers. So when this happens, what we do, the median is actually the mean of the numbers either side of the centre. So the centre point is where that arrow is, which is in between the 7 and the 8. So we find the mean of the numbers 7 and 8 because they're just either side of the middle. So the median, we're going to add together the 7 and the 8, divide by 2 because we're adding two numbers together. So in this case we've got 15 divided by 2, which gives us 7.5. Right, so that's our median and we can keep going. So now the next thing we do, sorry about that, I was just playing with a cable there, that'll come up on my screen record though. So 5-figure summaries is what we're looking at. So a 5-figure summary is used to summarize a set of data. It's in the title, summary, so it's used as to summarize. It's used later to make a box plot, which we'll come to when we get to it, but we need to know how to make the summary first. So a 5-figure summary consists of 5 things, and these 5 things are shown here. So we have L, which is our lowest number in our data. We have Q1, which is the lower quartile, which is the median of the lower half. We've got Q2, which is the median, which is also M. So Q2 and M are totally interchangeable. You can use either or. Further, like as we keep going through the notes, I'm going to use M rather than Q2. We have Q3, which is the upper quartile. So that's the median of the upper half of the data and our highest number. So quartiles, which is what we're looking at here. Quartiles sounds like the word quarter. So that's what we're doing. We're splitting our data into 4 separate sets and finding our medians kind of in there, and we've got our highest and our lowest number as well. So when we are generating a 5-figure summary, this is what we've got to do. So example as we're doing it. So to find the quartiles of a set of data, what we're doing, we split the data in half and then split each half in half again. So it's the same as kind of when you first started trying to find 25% of something, you'd find half of it, so you'd find 50% by halving, and then find 25% by halving again. That's what we're doing. So we split in half and then split each half in half. So creating a 5-figure summary for this set of data here. So I've got 12, 13, 16, 21, 22, 24, 24, 26, 28, 30 and 31. So I split it in kind of half. So we've got our bottom half, our top half, and then we have our median in the middle. So we have 5 numbers either side and then 1, which is our median in the middle. So now what we have to do is we now need to, once we've split it in half, we're splitting the bottom half in half and the top half in half as well. But for, like, we've got our lowest and our highest numbers, which are just as long as they're in order. So for a 5-figure summary, same as median, everything always needs to be in order, smallest to biggest. Our lowest and our highest are still included in our lists when we go to our next step though. So as you can see, we've got our bottom half, we've got 12, 13, 16, 21 and 22. Our median gets excluded though from our top half and our bottom half, it's on its own in the middle. And then we have our top half, which has got 24, 26, 28, 30 and 31. So in the middle of each of those halves, so Q1 is in the middle of our bottom half, so that's the 16, because that's the middle number out of those 5 in the bottom half. And our Q3 is 28, which is the middle of those top 5 numbers. So we end up, we can write our 5-figure summary. So we have our L, lowest number, which is 12, Q1, which is 16, M for median, but it could also be Q2 if you'd rather write it as a Q2. Each is the same, it's the same thing, which is 24, Q3, which is 28, and our highest, which is 31. So, same as what we were doing before, another example for generating our 5-figure summary. But this is kind of talking about in the same way that we had medians, we have an issue as well sometimes when this happens. So, if we're going to create a 5-figure summary for this following set of data, what happens when I split it in half? We end up with 6 numbers in our bottom half and 6 numbers in our top half, and the median is in the middle. So, same, this is where we have, if we've got even quantities of data, this is going to be what happens. If we have odd numbers, we're going to end up with numbers discrete, like numbers on their own, like we had in the last one. So either side of my middle, we've got 45 and we have 47. So we do 45 add 47, divide it by 2, and we get 46. So then we split it into quarters now. So see, because there's 12 numbers, each quarter contains 3 numbers. So our Q1 in between those two, so in between, so we find the mean from 39 and 40. So we're adding them together and halving them, which gets us 39.5. In between our third and fourth quarter, we have 49 and 52. So we're going to add 49 and 52 together and half it to get 58.5. So we can say there's our list of our 5-figure summary. So our lowest was 38. Our Q1 was 39.5. Our median's 46. Our Q3 is 50.5 and our highest number is 58. So that's us for 5-figure summaries. So we're always looking for those 5 numbers. So lowest, highest, and then the medians for our quartiles. So box plots. What is a box plot? So box plots are a visualization of a 5-figure summary. So graphs in general are all about visualizing your data, and a box plot is another way of doing this. A box plot is just a different type of graph, and it's specifically to do with our 5-figure summary. So we use the 5-figure summary to create a graph that looks like this one here. So we have a box in the middle and 2 lines going out, so that's why it's called a box plot. So the box joins Q1 and Q3 together, so the box shows in between our quartiles, and also has a line in there for our median. And then we have whiskers out to, like lines out to our highest and lowest values, and the fact that it's got these lines out to the edge and they kind of call them whiskers means that sometimes you'll see them called box and whisker plots, because we've got the box in the middle and then the lines out to the edge. So how do we create a box plot? So to create our box plot, what we have to do first is we have to make our 5-figure summary for the data we've been given, or if we've got a 5-figure summary, it's nice that's done for us. That's one less step to do. So we need to create a sensible scale for our data. So this is like we draw effectively like a number line along the bottom, and then we create our box plot above it. You have to make sure you pick a reasonable scale. So 1 box equaling 1 is not always sensible. It may be the case that you want to do 1 box is 2. It might even be 1 box is 10, especially if you've got big kind of jumps between your numbers. And then we draw in our lines for our 5-figure summary. So once we've got our 5-figure summary, we draw in kind of vertical lines, even up and down lines at those points above our number line, and then we can join them together. So we join the Q1 to the Q3 to generate our box, and then we draw lines out from the middle of the box to our highest and lowest values. So creating a box plot for the following data. So we've got our lowest is 38. This is the 5-figure summary we just did on that last page. So the lowest is 38, Q1 is 39.5, the median is 46, and Q3 is 50.5, highest is 58. In this case, I would suggest it's probably a good idea to have a go at trying to generate this box plot yourself first, so pause the video probably and have a go, see if you can create it, before seeing what it should look like based on what I'm about to show you. So this is what we have here. So this is the box plot that I've made as a relation of this. So we can see that at the bottom we've got a scale, so it's going up in 5s, but you can see that this box plot, the scale is 1 box is a half, but in some cases, like I said before, each box being 2 or maybe more than 2 could make more sense. But for this one, because we had the 39.5 and the 50.5, and it's only 20, like the numbers between our lowest and our highest is 20, it means that I've just decided to go for kind of 5 being 10 boxes, so each box is a half. So when I was doing this, what I did was, if you go along, we count up to 38, we make a little line at 38, we make a line at 39.5, we make a line at 46, one at 50.5, which I can see this one is actually incorrect, my box plot's not right, but I think what's happened is my 50 at the bottom is in the wrong place. 1, 2, 3, 4, 5, 6. Yep, my 50 is wrong. My box plot is correct. My 50 should be 1 over to the side, so just make sure you're being careful and not making mistakes like that one. And then our highest is at 58, which is fine. I think this is a problem with going on to with the PowerPoint, unfortunately. But you should make sure that yours is correct when you're doing this into notes for yourself. Right, so creating box plots, that's that one. So measures of spread is the next thing we need to talk about. So when we're talking about averages, averages aren't normally enough information. So when we're doing it, it's not enough just to look at our average, as it doesn't tell us everything about the data in relation to that average. So we need another piece of information, and the piece of information is about how the spread of the data. So spread of data is kind of how wide or different our data is. One of the examples that I use quite a lot is in a classroom, our mean value will probably be the age of all the pupils that are in the room. But if I'm in the room as well, then our data is not all going to be really, really close to that value because I'm older than everyone else is in the room. So my age does change the data, but it doesn't change our averages. Our averages would still stay the same. So what the spread is telling us is it tells us if the data values are similar or varied. So the larger the value for the spread, the measure of spread we get, the more varied the data is. At National 5, both for maths and for applications of maths actually, there are 4 measures of spread that we need to look at, and we're going to do 3 of them now. The last one you'll do later on, and the last one is the one that's kind of in common between both courses as well. So we have range, which we've done before. This is the one that's the revision. We have interquartile range, and we have semi-interquartile range. So let's see what they are. So our range, this is the one we've done before. So range is the difference between the highest and the lowest values in a set of data. So to calculate a range, what we're going to do is we use this. So it's the highest, take away the lowest. So all we're doing is we're finding our highest number in our set of information and our lowest number in our set of information, and that tells us the range of our data. So this is the one I kind of most often mention, kind of in terms of the example I was talking about in terms of the age of people in the classroom. If I'm not in a classroom, the range is probably 1 or 2, because most people will be the same age. So if you're you guys 3rd year, probably about 14 is going to be my mean or something like that. And your range is maybe 2, or range is probably 1, because there's only going to be people who are 14, maybe some people who are 13, maybe some people are 15, I'm not totally sure, can't remember. Whereas when I come in, the range changes because I become now the highest age in the class, so the range will become considerably bigger just because one other person has come in. So the range tells us that there's kind of this spread out of our data, so there's an extra number that's not quite like the other ones. So what we have next is our interquartile range, which is called an IQR. So inter means between, quartiles, we know what quartiles are, and range is the difference between things. So our interquartile range is the difference between our Q1 and Q3. So this one is often used because it excludes any potential outlying data. So it may be the case, for example, that you have, like I was talking about, you've got me in the room changing the thing, changing the information. So I'd be considered an outlier in that situation because my data value or my age is considerably different from the rest of the information. Or for example, say you have, if it's test scores or something, you might have that one person who decided on that day they didn't want to do it, so they sat there and they just put their name on it and nothing else. So you've got a 0 somewhere in there in your range and everyone else is getting really good scores. So your interquartile range can kind of exclude that information for people who are very different, either much higher or much lower than the other information. So our interquartile range is just our Q3, take away our Q1. And then our semi-interquartile range, which is the last one, which is SIQR. So if we think about the word semi in terms of maths, we all should know about semicircles, and semicircles are half of a circle. So our semi-interquartile range is half of the difference between Q1 and Q3. So it's just half of our interquartile range. So it is Q1 take away Q3 take away Q1 divided by 2. So one last thing we need to be able to do, which is compare data. So there's going to be examples, worksheets for you for those measures of spread, but I've not got any examples in here because they're fairly straightforward. But if you were wanting an example, feel free to comment or ask your teacher on your Google Classroom. So last thing is comparing data. So the reasons why we find averages and the reason why we find measures of spread, so our range or our semi-interquartile range and things, is so that we can compare one lot of data to another. Statistics is all about comparison between different things. So, in general, when we're comparing data, we cannot just state that one number is bigger or smaller than the other. So we can't just say, for this information, the mean is bigger. That's not enough information. We need to be more specific in what we're doing. So what we actually need to do is we need to use the context of the question to make sure that we're comparing our data properly. So for example, if the question was talking about times in a race, then you need to compare using words related to time. So for example, faster or slower. You can't just say someone's time was bigger. You need to go, this means that this person was faster. So because the number is bigger, that makes them faster, or because the number is smaller, that makes them slower. So we need to relate it to what the question's talking about. So when we compare averages, when comparing on averages, two averages, we need to start our sentences with on average because we need to say that we need to understand that we're talking about the average when we're doing it. And when we're comparing measures of spread, what we need to do is we need to show understanding that the spread tells us how similar or varied the data is. So usually, so with the comparing means or medians or modes, whatever you're comparing, you need to say on average to start it off. And when we're comparing spread, we need to show that we understand that the bigger the number we have for our spread, the more varied it is, or the smaller it is, the more similar they are. So example here. So we've got in 2018, Casey had a mean running time of 26.8 seconds in the 200 meters with a range of 2.4 seconds. In the 2019 season, Casey's mean running time changed to 25.3 seconds with a range of 4.2 seconds. So we need to make two comparisons between the data. So in this case, I'll say compare them. It might not expressly tell you how many comparisons to make, but we have means and we have ranges. So we've got a mean and we've got a measure of spread. So we can make two different sentences. So looking at the times, in 2018 our time is 26.8. In 2019 the time is 25.3. So we can see the time has gone down, but like I said on the previous slide, that is not enough information. What we need to do is make a comment on what that actually means. And we need to start with on average. So a good sentence, an example of one would be, so on average, Casey ran faster in 2019 compared with 2018. So because the mean running time was smaller, that means faster. So 25.3, smaller, better when we're running compared to 26.8. So we've got a good sentence there. So on average, Casey ran faster in 2019 compared with 2018. But then we need to make a second sentence comparing our spread. So we had in 2018 it was 2.4 seconds. But in 2019 we've got 4.2. When we're making this comparison, we can do it either way round. But in this case, what I have here, so Casey's times in 2019 were more varied than her times in 2018. So we can see because the range is 4.2, that means they're more spread out or more varied compared with the 2.4, which is a smaller number for 2018. But you can see in my sentences I've not mentioned numbers at all other than the dates. I've not said that Casey's time in this was 4.2 and her time in that was 2.4. That's not enough information for me to relate it to the context of the question, and this question was talking about time, so we needed to say faster, and her times were more varied. In this case, I think I said her, it could be his, Casey's, both, but okay. Right, so that's us for comparing data, and that's us for our different types of averages and spread. So I hope that's been helpful. Any questions you have, field them to your teachers in your Google Classroom, or you can put them on the comments here, and I will get back to you if there's anything specific that you've got. So thank you very much, and I hope that as a result of this you've kind of got a little bit more information on what's going on for statistics, specifically with averages as part of the National 5 course. So thank you very much. That's us.